All right. Hey guys, thanks for watching me again. Coding like crazy and trying to make this work in a different way. So for those who were watching before, I was working with the wavetable. So this morning I took some time to adjust the code and make it work with sim instructions and I added a float option to my sim instruction so I can test things better. And for the envelope, this already works. So this is my benchmarking tool. Let me try something here. I was testing a regular C code, which can be very slow for a few types of things compared to SSC. I'm still working on this code in here. It's not working yet. But let me test the envelope because I want to talk about something in here. Because one thing that you have to understand about SSE and AVX is that they have different latencies for depending on what you're doing. So regular code for the envelope is taking 25 seconds for this many number of samples. So one way to calculate this, let me put it this way. Let's say I want work for 100 samples, and I can calculate in a different way. 1 second is going to be 100% of the CPU usage. So I can put the value in here in percentage too. So let's say I get the numbers of seconds here. Times 100. Because 1 is going to be 100. CPU. Times 100. And I'm going to show just one decimal. And you should give me just an idea. This is just very basic. It's not really accurate, but gives me an overall idea. So you can see 2% on the CPU for the envelope using regular code. And let me put some stuff in here. CPU percentage, and then the time in seconds. And here is not SSC, just regular C++. Just a quick test, just to see how that's performing. And the wavetable code is showing 0 because I haven't coded it yet. So you can see that the SSC performs much faster. But there's a reason for that. One is because here we are looping. Let's see one thing. See if the loop is the one to blame about. So 227 seconds. Microseconds actually. I'm going to put in here if the compiler is unrolling this loop, unrolling, I don't know how to call that, unrolling, roll and to unroll. 37, yeah, it's pretty much the problem, not with the loop itself, but just the way things get computed. So if you just go one by one here, let's see if it makes a large difference. Not so much, pretty much the same. But what happens here, if you look at the SSC code, the instruction actually, most of the instructions do take just one cycle, but in this case, let's say we are adding 4 numbers with 4 numbers. You can see the latency is 3 for the newer processors and 4 for the oldest ones. I think Skylake is oldest, I don't remember. But you can see that you're not getting one cycle like when you do A plus B using regular code. You're getting a latency of 3 cycles, but it's still faster than having 4 cycles to process. Well, it's not just 4 cycles actually, because you're going to have much more, because you have to first move. Let's say you have A0 equals B0. Let me put this on my other window here because the font is larger. So let's say we have A and voice here. Voice. So we have like 4 int voice 0 voice and voice plus plus. And instead of this, you just go like, you load the value of A, actually voice doesn't apply in here, and you load the value of B, and then you just go A equals, actually not, you store the sum A and B, and we store actually to A. So the SSC code, even with the latency, so this here has a latency of 3. Let's say on the best case, the store, let's see the store, what's the latency of the store? RPS. Latency of 1. And that's just ridiculous. It's very fast. And let's see what's the latest of the loading. Latest of loading is also 1. So we have 3, 4, 5, 6 cycles to process that. While on the above code, it's going to take much more than 6 cycles. So you can see why SSC can perform much faster. But there are a few problems. Before, for the envelope, yesterday I was taking a look and I found a problem in the envelope, because I need to know if all the envelopes are 0 and in the release or the decay stage, and if they are, I can set the whole synth to idle and not process anything. But for that I have to check the value of each voice. So before I was doing something very simple actually. I was checking if voices are equal 0. If it is, it's going to report me all the bits as 1. If it's not, it's going to report all the bits as 0. And then I was masking it, copying the mask of all the 4 or 8 values into an integer. So if they were going to be all zeros, the integers will be 0ff. So that takes a bit compute. And I was thinking, maybe I don't really need that. I could just go and add a variable called sum values, and I just go summing. So for the first voice, I set the sum values to 0, where I do the start voice. Sorry. And then let me adjust the camera. Just something here. And then I just go adding to the sum values the latest value that I use for the output. And then on the check idle, I don't have to use SSC. Or AVX. I just go checking all the values, if they are 4 or 8, one by one. And if it finds one that's above 0, it just sets the idle to false and breaks the loop. You can see the loop in here. And this is much faster than just using the SSC to check and create a mask. And I did benchmark that, so that's why I know that. So it's always good to benchmark. So now what I'm creating, it's just a small code for the float values, because I want to start messing with the wavetable code. But I want to do this in a way that I can test as a regular C code and have the output stored to a temporary variable, and then check with SSE if it's going to work correctly. So at first I was going to use a float sim, a kind of sim code, but that didn't really work the way I wanted, so I'm getting rid of that. So I'm just going to go back my regular tests, and I'm going to first finish a few things. Just let me fix a few things in here. So I'm testing now. I'm going to remove the CPU's age because I don't really like it. I rather have the time instead to show. And of course, I no longer have this one for the wavetable. I have 3, 4, 5. I forgot to copy values in here. What is it? SSE processing. Because in my benchmarking, I also check if the values are going to be the same So use the wavetable code, and I get the final values copied from the output of the wavetable. Okay, that was what I had before. So for the wavetable now, there are 2 things that I need. And was thinking a way of having two wavetable objects. I switching again today. So let me do the first basic stuff. Because I need to convert. Let me check one thing. Convert to integers. Because I was hoping I could have the first thing I have to do, I have to get a position and get only the integer part of the position. So that's going to be a problem in my coding here. Because in this case, I need to be able to process 4 or 8 values with the same code, like I did with the envelope. But there is one problem here. I'm going to have to I'm going to need two codes actually. Process voice and mix voices. I'm going to have samples. I'm going to need two samples. I'm going to use linear interpolation instead of Hermit or 4-point line interpolation, because with linear interpolation I can oversample multiple times and I'm going to get a very good result. And if I don't, I just do the 4-point line interpolation later. But for now, I'm going to use this. Let me reset the values. It's always good to not have those values as undefined, because I'm going to fill them up before I use, but it's best not to worry about that. So process voice SSE, okay. And then I'm going to have another one. It's going to be mix voice. And then the mix voice I can use a template. So okay, the first thing I have to do is get my values right. I'm going to have my two samples, and I also need the interpolation value. Samples interpolation from one sample to another. I'm going to also create this to have my sample and my sample interpolation. I have a position and my rate. And I'm going to have to process voices of SSC and AVEX. Well, actually, I'm going to have two. If I don't need two, I'm going to check that first. Because the first thing I need to get is the values for each position. So I have position int for. I was hoping that I have a conversion from floats to int that process 4 floats and gives me 4 ints in the same call, but I'm not seeing that. But I think there is such an option. Let me check my from with SLC first. I don't think SSE has that. Convert a packet single position 32-bit floating point elements into packet 32-bit integers in result stores. That's the one. It has a latency of 3, which is very good. So I could go I need to store this somehow. So I'm going to require SSC2 for this to happen. It's not a big deal. So position integer equals and get position plus voice. Of course I have to load yes, position voice. Okay, if I understand correctly, now I have all the integers in there. So I need to create for values. Just have to check how to store. Where's the store options? Oh, never mind. I'm not showing. Oh, here. I think only SSC2 has this store, the integer. Okay, my memory must be aligning. Of course, I was expecting that. Use align integer, and I don't need to use that. I can just go and store directly the results of my conversion into position integer. Okay, what I did wrong? Oh, okay. It's on the contrary. It's always the memory variable first. I don't get this. How the hell do I store that? Maybe I'm missing something. Double. That's weird. Maybe it's not store, it's convert. I'll convert is what I'm already doing. Oh, I have more options in here. Let me check. Double. Starter to integer a. No, not that. How the hell do I store this in a way I can use later? I don't get it. Internet is your friend. Invert. Aligner. Oh, interesting. Okay. That's interesting. But why unaligned? It's not a problem. I just guessed. How should I know that? Anyway, okay. I have my 4 values as integers. So now I can load my samples. I need the current sample. Zero equals owner. Here, yeah, in the wave table, you just get the first value and then integer position 0. But since I'm doing linear interpolation, I also need the second. And one thing I can change is on my wavetable code. Let's say envelope, because I have 1200. That's a wavetable size, and I can have 1201, because that way I can load without having to do any checks the next sample. So I can just go and go position +1. And when I create the wavetable, I must know that the last sample must be a copy of the first sample for this to work correctly. And don't do any noise, because one time I forgot to do that and was presenting some noise, and I almost went nuts trying to figure out what it was, and it was that. I forgot to copy the last sample that I was using. But now there's the interesting part. This is going to take several cycles, but we could use SSE to load this faster. So we can use the load option and load 2 values. So let me check with SSE2 if it has a load high and low option. It has for PD. Let me see if SSE has for SPS. Load high an integer. Load to single precision. Okay, that's not what I want. Load PS1. Load high, load low. Reverse order. SS3 and 4 doesn't have much stuff. But what's the stream load? I don't remember. Okay. Those are all not very useful. I remember having an option to load low and high, load just 2 values instead of 4. It's not showing me the cycles impact. Well, because it's from memory, so it could take as long as memory takes to load up. Well, I'm not going to bother with this now. I'm going to test this first. So I have my two samples. I must do this 4 times. So 0, 1, 2, and 3. 0, 0, 1, 2, and 3. So I load all the 4 voices, the 2 samples. I have my integer already stored to positional integer. Now I need my interpolation rate. So samples interpolation, not rate, sorry, just interpolation. So the interpolation is going to be 1.0 minus the fractional resulting of my position voice 0 minus the integer. That's interpolation. So as the position is close to a round number, like 1, 2, 3, the interpolation is going to be 0. Actually, this is going to be 0 because I'm getting the whole thing minus the integer part. So let's say it's 1.3 minus 1, so it be equals 3. And if it's 1 minus 1 equals 0. So the samples interpolation is going to go higher as it go close to the next sample. So that's correct. And I have to do that for the 4 voices too. Okay, I have my sample interpolation, my samples. And I'm pretty sure that I can improve this a bit with some SSC code. And for that, I'm going to do some benchmarks. First, so the process voice is not going to be a template because it can't be, sadly. Let me disable the other guys in here. Hey dude, what's going on? Well, not with these names, sorry, so many names, but sorry if I don't remember. Process voice SSC. And this guy I'm going to disable. I'm doing fine, thanks for asking. Hope you're doing fine too. Today I'm going with some crazy code in here. Hope it works great. So that's a very large impact, 4.8 seconds for that many samples. Much more than a wave envelope, sorry. But that's just how it works. So I'm going to lower a bit. Oh yeah, I remember that. Thanks, man. Depression sucks, and it really it's really a big deal. And sadly, it's happening more and more to people. And I'm also bipolar. A lot of people already know this because I made two videos about that. I'm not going to talk today again because there's the videos already. But there are days that is okay. There are days that's not so okay. But just how things are. But I'm doing much better. I'm working more. Still making a lot of mistakes in the code, but that's normal. So I'm glad you're doing better, man. I can only imagine how hard it can be sometimes. So let me just write this. These are the benchmarks for the envelope. Oops, that. Envelope. Wave table. Thanks, man. Hope you're doing great, sure. I really appreciate. And okay, let me check here what's happening. Okay, so I'm getting my samples. What else do I need? I have the samples, the interpolation value. Now I need to accumulate my rate, the position with the rate. But before I continue, let's take a look and see if I can improve a bit this code. So for that, I'm going to make one change. Instead of just one extra sample, I'm going to add 4 extra samples for each wavetable. 3 actually. I think it's 3. I'm going to put 4 so it's round number. But instead of just loading one by one, I'm going to go and load like this. So store, yes. No, it's not like that. Wait. No, it's not like that. Load yes from the owner wave tables plus the position of the voice. So this is going to load four of the values at once. And now I just have to go and store this in a better way. Thanks, man. Let me think over this. So the samples, because the more I process with, how to say that? The more I process in a serial way, yeah, that's the one. The better it's going to be. So I have my samples value, and I want to store that in a different way. No, it's not going to be like that. It's a bit complicated, but I can do it. I just have to think a bit. So let me try this first. A, B, C, and D. so I see more what's going on. So now I need to store that. Because now I have my samples, so I have my samples 1, 2, 3, and 4, all like that. And if I'm not mistaken, there is a way for me to shuffle this using SSE somehow. I'm trying to remember the name of that. It's not beat manipulation, is move. Moves the upper two elements from I think it's move. It has a latency of 1, so that's good. Let me see if SSC2 doesn't have something a bit better. No. I really hate the way they explain things on the Intel side. So I think move high, move low. I remember a masked move or a shuffle that I could do, but okay, this is the low, but I need the low to high. So I have a really hard time trying to understand 0 to 2. So it's the first, the second. Let me see if there is a picture of that, because I really hate the way they explain stuff there. I don't know, use pictures, I don't get that. Let me see something. Let me open another page. So let me try to understand what this is doing so I can make my code around it. Because this really looks alien to me, to be honest. So it looks like this is 0, this is 1, this is 0, and this is 1. And then destination 0 and 1, 2 and 3. Because it's 32 bits each one, so it's 32 plus 32 plus 32 plus 32, no, 96. Yes, 96. So v1 equals move that v0 v1. Okay, so now we have v0 0 v1 v01 v10 v11. v01 we can be voice 3 and 2. Now I have voices 2 0, voices 2 1, voices 3 0, voices 3 1. Yikes. And now I have to store this into my samples variables. And that's the crazy part. The best thing right now, I'm just going to create a temporary place for that, or don't really need to create a temporary place. So let me think on this one. My samples, what if I store? Store voices, float, and the v01. Oh yes, samples 0. Now I just need to shuffle this thing. And that's the complicated part. There's no shift option. Hold logical mask. Move mask. Move mask doesn't help me. Already tried. Let me check the store option. Impressive that it has a mask option for moving, but not for floats. Oh, I have this store holding high, but not for float again. Hey man, nice to see you back. Fighting a bit with my coding here. Reverse order doesn't help me. And then the regular store. So what I'm looking is to shuffle the values. And there is an option to shuffle, but Not in shift, nothing logical. Where the heck are the shuffles? Shuffle single precision floating polynamials in A using the control in store. Yeah, that's the one I want to use. Okay, so what I'm trying to do is getting the code for loading the samples to load much faster. So I have my samples loaded into 4 SSC variables. Then I have moved the low and high portions of the samples. So I have voice 0 sample 0, voice 0 sample 1, voice 1 sample 0, voice 1 sample 1, and so on and so on. But now I need to shuffle these into 2 variables that will have everything. And I need to use the shuffle option. I don't remember if there is a tool to help me out with this. Because it can be a bit boring to use. Oh, there is a shuffle option. I've never seen it before. Doesn't show in here. Here, that helps a lot, actually. Well, but there is a problem. Because what I want, oh come on, what I'm doing? What I want is not actually shuffling this way. It helps, but let me think a bit. I remember a very long time ago I had the same problem with the loading of samples, and the problem is that I don't remember how I did it, but I was using a shuffle like crazy, and that doesn't help. Use too many times. It's best that you get things done in a more direct way. With AVX, it's much easier, but with SSC alone, not so much. What was that sound now? So let me check, because there is an option of moving things out. I have the shuffle, but I also have the move option, which is what I have used already. Yeah. This is a brain scratcher. What I was looking to move. Let's take a quick look at shuffle and see if there's other options. Nah, not many options. Actually. Well, one option is to get this result here and do a and yes with I lost my slippers. I'm going to go no stories first. Or voice. Let's call this final voice and get a copy of 01. But I'm going to shuffle this or have the first two voices in the starting point. So let's see if it works. I'll do the end later. Full yes. B0. The strange thing is that I can get from two values, but it's not showing to me in here. It's showing the A and B. Because I'm trying to understand I see now. I think I get it now. The first two values are from A and the second two are from B. Yeah. First two are from A and then from B. That's actually very useful. 01 and then what is the helper they were using, and then here we are. Shuffle, and it even shows micro for shuffle parameter. Okay, so the first one from, it says there it's from B, but it shows in here that it's from A actually. Huh. Who do I trust now? From argument B. Oh, bloody hell. There must be a better way to understand this. Ah. Where's my option for images? GHAB. What the hell? Ah, okay, I see it. A, B, C, D, E, F, G, H. Yeah, that's not so bad. So, okay, the first value on the shuffle selects the value on the B. Okay, so 1, 2, 0, 1 goes for, oh yes, 0 to 1, 0, 1. 1 is G, then 0 is H, then 3 is A. Okay, that actually makes sense. And I'm going to write this in a way I understand better, otherwise I'm going to go crazy after. But what I need in here, I want so it has to be 1 and 0 because I want from A first. Want this 0. Zero, 1 and 2, and then again 0 and 2. That should get me voice 0 sample 0 0, and then voice 1 sample 0, voice 2 sample 0, voice 3 sample 0. At least in theory that's what it should be. I have to double check that, but it looks good. 2 and 3, 0, 3 and 2. It should give me the other guys. So now I have all the, now I can go, I have to change here now. 1 and 3, 1 and 3. No, that's all wrong. Oh boy. Oh, of course, I'm doing this wrong. Let's use V01 and 23. Crap. And then get from B. Why they make this so confusing? There must be a better way to understand this. No, not the one to get confused with this. And funny thing is that there's not many information around. A single example. Let me see if I can understand this example in here. Okay, let's control 0, 1, 2, 3. For parameter should argument that P3 is a digit, send F from parameter B, FPT of result. So it goes like B, B, A. From what I understand in here. So I want So let's start with A. I want A0, which is sample 0, A2, and then 0 and then 2 again. Now that's correct. And now the final value is sample 0 and sample 1. and now I want the sample next to it. So start with it. 1, 3, 1, 3. That's correct. Now store directly. Samples, voice, all this. Oh, it's sample 0, choose voice, and all that. Ah, interesting. Okay. And well, let's see how if that compiles correctly and what's the speed compared to before. "46. Well, it did improve the speed. You can see by half. So that's good. I just hope the values are correct. So a way to check that I'm going to sorry guys. I'm thinking a way to double check that, but I have no idea if that's correct or not. The theory is good, but who knows? And I have to check if this is SSC1. Yeah, it's SSC1. So I'm still using SSC1. So now I have the samples. Oh, I forgot. This is wrong. So maybe it's not going to be half the speed. I was putting the samples in the same. Yeah, almost half. 49 is too good. Let's just put 49 in here. With it's too half. And okay, shuffle works. Just thinking on how to double check if that's correct. I'm going to see if I can load directly instead of using a memory pointers. Let's see if that helps with the speed as well. Otherwise, I'm going to leave it like that. Maybe the compiler takes the care. Now it's faster. Always good to check. And also this guy here can be declared outside, so it doesn't have to be redeclared every time. If the compiler is smart enough, it shouldn't be doing that, but sometimes the compiler is really not that smart, so best always to test. Hey, it got worst. Okay. Let's leave it like that. Maybe the compiler sees that next to this one and runs faster. From what I can see. Or maybe the problem is not that, it's because everything's aligned by 32. So that's aligned by 32. Let's see if that helps. No, it doesn't help. I'm going to leave there. So I'm trying to think now a way to double check this. So what I'm going to do, Let me do a quick check in here. Just a small hack, just to double check. Samples, play tables, position 0, 1.0 F. Actually, don't have to bother about that. So I'm going to put these waypoint pointers as fixed, just so I can test. 0, 1, 2. And 3. Then I do all this stuff in here, and now I check if some pose 0, voice 1, it has to be 1.0. And then the second one should be 2. Now let's try. Oh, sorry, it's not like that. Yeah, it's like that. Voice 1 is 4 and 5. Voice 2, it's 8 and 9. And voice 3 is 12 and 24. What? 14, let's put 24. And let's see what happens. Okay, someone's messing up, so let me double check. View position 0, position 1, 2, and 3. 1, 2, 4, 5, 8, 9, 12, and 14. 0, 1, 0, 1, 0, 1. Then samples 0, 1, 0, 1, 0, 1. Plus the voice. Now, let's debug. Let's see what's going on. That's not going to work the way I want. Try something else. 1, 2, 3. Okay. So let's see. Close. Test for. I have to declare a line edge. I already created that. Test. Store. Store. Yes. Test V01. 2. 23. These are only. Now I'm going to check what's the output of those two variables. 7878. Okay, that's not right. 7878. Yeah, that's not good. But well, I'm not computing the position, so the position is always 0. Position 0. Okay, I see. Okay, I see a problem in here with my test. So it should not be like that. If I test this, make a quick change in here. Okay. Then I'm going to force the positions. Position 0 equals 1. 0, 1, 2, 3, 1, 2, 3, 4. Okay. Now it should give me a better idea what if it's I don't know if this makes any sense, but at least it should. Put this in here. 1, 2, 3, 4, 4, and 5. Interesting. Position integer 0, 1, 1. Well, of course, I'm hard coding, so of course I'm going to show 1, 2, 3, and 4. But well, actually, it does look correct. So now I'm going to put come on, sample 0, sample 0, 0, sample 0, 1, no, sample 1, 0, sample 0, voice 1, sample voice 1 again. Yeah, that's correct. It was 2, 3 actually, but 2, and then the final voice 0, 2, 3. It looks good, but just so it's a bit far away from each other, I'm going to do like this. so it's more easy to see. Oh yeah, sample 1, 2, 11, 12, 21, 22, 31. Yeah, it works. And it works quite well. I'm going to leave this comment if you need to check again, do some testings. The code is there already. And let's take a look if there's anything I can improve. It's still in debug mode. Let me put in release mode and test again. But you can see that the SSC code for this case runs much faster. Now I need to check. Okay, let's see if I can explain. I need to load 4 voices. Each voice, I need 2 samples. And doing that using regular code was taking 1 second. With this code, it's taking half a second, so it's faster. So I'm loading 4 samples for each voice. Then I use the move low to high function on SCC to take the low and high portions of each voice. In this case, 2 voices from voice 0 and voice 1, and then voice 2 and voice 3. But now I need to shuffle the values so I get in one variable all the voices first sample, and another variable all the voices second sample. So I can do the linear interpolation with 2 samples. And it's still loading much faster comparing to using regular code. Now I want to check one thing. I want to load back the integer values. Well, just to check something. Just reading something someone posted. Just to check if I need to reply now. Okay, sorry, there's a lot of stuff going on. I finished the envelope, and so I'm working on the wavetable now. And loading samples from memory can be a pain in the neck. I'm just going to use linear interpolation with oversampling and with a good filter. And if I see that's here, that's not working very well, I can check for 4-point interpolation, also as known as Hermit interpolation. But the math is very crazy, so maybe it's faster to use linear interpolation and oversample more comparing to oversample less and using Hermit interpolation. And I also need to do bottom interpolation. So when the rate is lower than 1, it has to interpolate slower instead of a linear interpolation that usually happens when you're working with a fast moving, like 2, 3, 4 rates. So that's what's going on. So what I want to know, if I can truncate no option for that, I guess. I want to convert to integer and then back. So let's see if this is option. I'm just going to clear the chat window here so I don't get lost. But you guys can keep writing just so I see from the corner of my eye that someone's writing there, and I can reply quicker. There doesn't seem to be such an option here. I guess as I'm already using SSC2. Let me take a look at this guy in here. Yeah, that's SSC2 already. That's not good. Because I want to get the integer part. Maybe it should be something like round. SSC2 round. And there's the floor function. It's showing you that. There's the round and the floor. Round depicts floating point down to an integer value in stores of a single precision floating point element. Yeah, that's it, but that's a SSE4. Now let's compare that, because I don't need to really work like this. Oh, actually I need a value so I can load from the position of the wave table. Well, so all I need to do is load it back. So I need to convert back actually. So I want to load. It's a load operation, but Let's load a single one. How the heck do I load? I'm overlooking something, I'm pretty sure. Let me try something in here. Let me see if that's going to break the speed too much. Well, marginally, not very much. Okay, so how do I convert these back into a float value? Integer is root. Yeah, that's the one. That's the one I want. So I get the input, which is going to be this guy, and the output. So I get the position plus the voice. And this guy, and I want to do subtraction, a packet subtraction. So I'm going to subtract the whole number with the integer converted to float point version of it. And now I can store this to my sample interpolation variable. And then we check if that helps a bit or not. Let's see. Yes, it helps a lot. 35 seconds now. Oh yeah. So you can see from 1 second now to 35 milliseconds. Yes, I think it's milliseconds. Yeah, I think it's it. So what I'm doing, first thing, I'm using the conversion option from SSE2 to convert my floating points values, the 4 voices, positions, from float to integer. Okay, then I converted it back to floating point, but I put in a different place here. So then I subtract the original value, which could be like 1.3, with the integer version, which will be then 1. So 1.3 minus 1 is going to be 0.3. And that's my interpolation value that I need. Because I need to multiply that with the 2 samples that I have loaded to memory now. So that's pretty good. And just to be sure that this is not breaking the code, let's rerun my debugging tests in here. Not that we need, but it's always nice to do that. 2, 11 to 12, 23, yes. So you can see here on the bottom, I have set positions for my 4 voices that I'm testing right now. So I set position 1, 11, 21, and 31 for voice 1, 2, 3, and 4. And the samples, I have set my wavetable samples to go from 0 to 1000. So it is loading correct samples now. So samples for the first voice, sample 1 and 2 is 1 and 2. Voice 2 is 11, 12. Voice 3, 21 and 22. And voice 4, 31 and 32. So that's working correctly. I'm going to leave this testing code now in here just to be sure. And well, that's about it now. That's the process voice. It's going to load all the voices. There is an option, but I never got it to really work, which is the prefetch. Doesn't even show here. It's not showing. Prefetch. Fetch the line of data from memory that contains address to location cache specified by locality hint L. So, well, I never got this prefetch to really work. But depending on the code, it can help out. But so far, I haven't got much into that. So I'm not going to bother too much right now about that, but it is an option you have. So if you know what you need to load next into memory, you can prefetch the memory. It's going to be in cache instead of the memory the next time you need it. But in this case here, I don't really know how to do that, so I'm not going to bother much. Now I need to do this for AVX2. Let me see if my coding here is already activated. So process voice with the OSSE. I need to do the same thing for AVX. Eight, 16, 24. 16, 24. So now, let me copy this whole thing here and start parting. I'm going to put X in here just so it doesn't get conflicted with the previous definition. So let's see if AVX has an option to convert to integer as well. Yes, it does have. It can convert 8 numbers to integer. Eight numbers. So we just take the same SSC code and add the process in 8 numbers instead of 4. And the nice thing is that all the calls just add 2256, and it's going to be the AVX code. That's very nice. I'm going to leave my test code in here and just expand it to 7 numbers. 5, 6, 7, 31, 51, 61, 71. And now I need more voices in here. 3, 4, 6, 7, 4, 5, 7, and 256. This is a bit overkilling, but it should work very well. But now is the shuffle is going to be a problem. Okay, there is no move high and low. So let me check if the AVX doesn't have any other options for loading that does that. So there's the broadcast option. No, that's not it. Load PS just loads the 8 values. There's a mask load now. Let's load unaligned. What's this one? No, that's not what I wanted. Load accuracy and precision into using masks. Huh? Brain exploding. Because, well, we don't really need to use AVX for the whole thing, I think. I think it should be possible to use SSC for the rest of the code. I don't know if that's possible or not. So let me take a look. Load mask. No, it's just had zeros and ones. Doesn't help me a lot. Yeah, I think I'm just going to keep the SSC code and just do it 2 times. But here on the top, I can use the AVX code. So I have all my variables here. And I need to do this 4 times. 2, 3. Sorry, guys. 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Now the shuffle needs to be done in a different way. Plus 4 plus 4. So 0, 1, 4, 5. 6, 6, 7, 4, 5, 6. I think that's correct, but we'll have to check. Let's see what happens. So you have the SSC code and the AVX code. 1, 2, 11, 12, 23, 3. This. The other samples. 0, 4. 1. 5. 1. That's not good. 6. 6. 1. 7. 7. 1. Let me check my values in here. And this seems to be correct. Just thinking, put 2000 in here. Okay, so let me double check things out now. The voices. Voices position. I'm getting 8. Let me see if I'm processing 8 by 8. Yes, I am. So let me check. Sample 0 and 1. Voices plus 4. That seems to be correct. Let me check again. Maybe I'm doing some mistake in there. Oh yeah, I didn't, never mind, it's correct. It's totally correct. So let's try with the release and see what's the speed all about. 32 for the SSE. It looks like the AVX, I'm doing something wrong because it's taking much longer. Let's take a look again. So this was 08 16 24. Oh yes, of course. I forgot to remove the test code, and that slows down a lot. Oh yeah. So you can see the AVX runs a bit faster than SSE. Not a lot faster, but maybe we can figure out a way to run even faster. Because the thing is, I'm using AVX on the top in here to start, to get my integers, and then back to floating point and the sample interpolation. It's all in there. It's processing by 8. Oh, there's another thing I forgot to add on these processings. Because I want this to be inline. It's large, I know, but it's only going to be called in one place, so it should always be inlined. The other calls, not so much. Don't know if it's going to make a big difference, but let's see. Yes, it does. Okay, that's a big difference. Let's put this on my list in here. So just by inlining, I drop it from 35 to 29 milliseconds. And if AVX is running 0.26 seconds. Switching again, sorry. So now I wonder if I can improve my loading of the samples in any way, but I don't think it is really possible. So I'm not going to mess with this part of the code right now. So instead, I'm going to go to the mix voice portion now. And this also has to be forced in line. And the great thing about the mix voice code is that it should take care of all of the math right now. Where I am. Here. The wavetable objects. And I have to mix. So it's going to be mix voice SSE, because then this can be a template. 4, 8, 12, 16, 20, 4, 8, 12, 16, 28. This is for SSE, and then for the AVX. Now, you're probably thinking, why use 2 calls? I'm going to explain now. Because the first call, we have 2 functions, one for SSE and one for AVX. And the way I need to load the memory stuff, I could use a template, but then there are a few problems. Oh, I could use a template actually. I just have to add more options for my sim instruction, and then I could have everything in a single place. It gets more complicated, but for now I'm going to leave like this, because then I have my SSE code here to load the samples, the AVX code to load the samples, and now on my mix voice I can do just like I have done with the envelope. If you look at the envelope code, which is around here, is the envelope code. It's very short code and works both with SSE and AVX, so it works both with 4 or 8 voices. And that's pretty much what we are going to be doing now. So the first thing I have to do is get my position and move to the next stage. So I'm going to use voice again. V is for the voice. I just created a macro here. The value plus the voice. So actually I'm going to go like this. T equals the position. Now I need to add the rate. And then I have to check if the rate is higher than the greater than 1 or greater than or equal than 1. That always get me confused. But I'm not going to have reverse in here, so I'm not going to bother. So position. I want to create a function here on my sim functions. So if it's greater, I have an equal for add, but I want a greater than 1. Just going to create another one here. Greater 1. Subs, just subs. And then the value. It's a very simple function. So how do you do that? Compare greater and equal. So compare greater, equal and greater. Now what's the name? I keep forgetting. Compare greater, equal. What's the when it's greater and equal? Greater. Oh, here. Greater and equal. Okay. If the value is greater and equal than 1.0, we use the value, which we're going to subtract. Oh, no, it's not like that. Greater and equal, subtract. I need two values actually. Value 1 and value subtract. So if it's greater and equal than value 1, because the value is not going to be 1, and then we subtract values, subtract, and return that. Actually, value equals value, and return Nice. Let me just check whether there's a mistake somewhere. And subtract. Subtract that value with that. Where equal greatest value 1 and the value. I'll subtract the internal value with the value. Okay. That's a bit crazy, but it can help me out a lot. So just create this on the SSE, and now I just copy to the AVX and put the right names. Why this? Because it's going to run much faster than just going to use equal and if, then, subtract. This just does it all in a single line. And on the AVX, things are a bit different. Subtract, and the compare is in different format. Greater than equal 31. Okay, that's done. That's simple, and it should work. So what you do? Position greater equal and we equal then. It should be the wavetable size. Relative size, and if it's greater than that, we subtract that position. Well, maybe I'm going to just make it like this. Value check and subs. That way I don't have to pass two values. Value check and value subtract. Because most likely I'm going to use always like that anyway. And that's the nice thing about having my own library for the sim instructions, that I can add all sorts of crap in here. As long as I understand what's going on, that's good. So, okay, I'm adding to the position the rate, checking if the rate is not higher than the wavetable size, the position, sorry. And then I have to write this back to the position place. And I want to check if I can make this run faster by doing a different way. To have 42 and 37. Let's check. Position T. I'm going to go like this. T. Voice position. I could create my own call for the rate. Let me try something. Add. We're going to add and then do all the checks all in a single call and see if that helps a bit. It gets a bit more convoluted, but I can use this for several places. And I have to do it here. Yes. Nice. Let's see how that works out. Did something wrong. Wait. $41.36. Yeah, it runs faster. So I know that I get the position and add the rate, and if it's greater than the value of the loop of the wavetable, the size of the wavetable is greater or equal of that, it just subtracts itself. So we can do a test now. Actually, not yet. I have to first add the output. Just let me write these numbers in here, just so I know where we are in terms of usage. I'm putting in here. You know, this type of instructions can be really handy to speed things up. So now I have to output this. I'm just going to quickly add the output in here. I don't need to go like that. I have to get the sample value. Samples 0. And then write to the output. Not doing any interpolation or anything. I just writing directly so I can at least hear what's the output. It's going to run much slower now because I added something, but it's still good. Now I can add this to my Wusik ZR code. So, okay. Changed a few things on the envelope now to make this work. Let's check idle again. I don't remember. Let me check this table. Wave table, no, the envelope. Start voice and check out the number of voices. Okay. So just check idle 4 voices. That's what I changed. 8 voices. So what else? I changed the call too, so let me check. Okay, let me process this correctly. Process for AVX, but then no, not like that. AVX 0. 16 and 24, and then we have to mix the waveforms. Where's my code now? I want the wavetable. Process voice and then the mix voice. Okay. Process voice, mix voice, AVX 0, 0, 8, 16, 24. 16, 24. That should do it. Or not. Okay, let me recheck my stuff in here, just in case this is not correctly loading. Update rate. I'm probably missing something, that's why it's not making the right sound. However. Just a minute. Just a minute, guys. My wife wants something. Okay. So let me double check what I'm doing here, because I'm probably overseeing something. Table start process. So check on the benchmarking here. What else I need to call? Change waveform. That's for a new node. And that's correct. The processing voices. So it looks like it's not moving the radar. Probably forgetting to write something. Let me think. Actually, this is done last. First thing I process the wavetable, and then I process for the next point. So let's take a look at this guy in here. Here, header creator. So first I add the value to the rate. Okay, that's correct. And then I compare if that is higher than the wavetable's size, greater than equal, and if it is, it's going to output me all ones. Then I do an AND with the value to subtract, and then I subtract. And if it's 0, it's going to subtract 0, which is the same as doing nothing. 1 minus 0 is 1. Yeah, that's correct. And the value is going to be that, and I return that as the value. And I write it back to the position. And I'm getting the samples from part above. It looks good. It's higher than 1,000 and 200. Correct. So just for the sake of testing, let's try this. Output 0 equals sample 0. Position 0 and then place 0. If position 0 is higher and equal than the wavetable size, let's subtract that. At least that it should be doing. Oh yeah, sample 0, 0. The first sample. Then I have compiler here. Oh. Nice. Not nice. Crazy. Of course. Never mind. Voice. Sample 0 voice. 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 Crazy, really. I was doing this for each voice and okay, where's the release? Let me add a longer. That's so weird. But it's actually correct. So let me try to see if my samples can have the output, and then I just do the position instead. Just to check where I'm doing something wrong. Because I'm doing something wrong, I just have to check where. Error, syntax error. Where? Oh, here. Don't want that. No, without interpolation, it sounds terrible. Okay, my add greater equals subs is not working. Well, I did look to several libraries, and to be honest, they don't have all the flexibility I have by creating my own code. And I didn't understand much of the libraries in a way that the benchmarks were terrible. For instance, Juice has a DSP. Nothing here is not going to show. Juice DSP. I don't have it here. I think I have it here. Juice itself has the DSP, but when I benchmarked it, it was just terrible. Very, very bad. So I just gave up on it and started to create my own. And my own is not that bad. It's just SSE and then AVX with FMA3. And I kind of understand what I'm doing here, so it's not a really big problem, but I know people like to use other libraries, but I'm one of those guys that really don't like. My nose starts to run. Yes, I could live like that and say, hey, look, it's an 8-bit. Good one. Sounds so strange. Let me think on something here. I could just call this. I'm just trying to figure out what I did wrong in here. Okay, I'm adding. The first thing I do is add the position. Yes, I can use that. I can just go like my own variables here and go like do plus, equal, all sorts of stuff, but it runs slower, much slower. I tried that already. I spent like 4 days just messing around with that, and I really hated how slow it was. That's why I'm trying to create the calls that are very, very quick. So what I want now is to add position to the rates and check it against the wavetable and then write back to the position. So the code looks correct. I don't know why it's not working correctly. Let me check again. I just have to do something for someone. Just a minute, guys. Just have to process something. Okay, that should do it. And don't forget that I'm very much older than most people, so I have a very hard time understanding things. This mess I've created, I actually understand, so that's why I'm sticking with that. I'm going to try the SSC code first, but it should be working. I don't know what's not working. I can force it to work with the SSC instead. Is it? Or here? Process voice. Okay, this should at least give me an idea where the problem is. Okay, I'm starting to think I did a mistake. Yes, I can do that. I have done some options here and there, like the define of the V for the voice and stuff like that. Not so big, but it kind of works. I'm trying to remember. I don't think I can use this like the way I'm doing here, because there are some limitations to this template. For I'm trying to remember what are the limitations, but no, it's not that. Let me go back here. So, okay, the rate and the wavetable size. If position is higher than the wavetable size, let me check again. So the first thing I'm doing here is I'm adding to the rate, then I'm compare greater and equal. But let me check if this greater than equal is correct, but greater and equal. Yeah, that's correct. If it's greater than equals, it's going to output me 0x all the bits as 1. So if I do an AND with the resulting and the value to subtract, which is the same value to check, I'm going to have the value, otherwise I'm going to have 0. So just for the clarity of my mind, to be know that I'm not crazy, 89 minus 0 is 89, of course. 1 minus 0 is 1. That's correct. So V, which is internal value, which is going to be the position, equals V minus the check. And I return V, which is the position, which I store to the position again. So I don't know what I'm doing wrong, to be honest. And it's correct. I'm adding both values. There must be something I'm overseeing. The hard part about the scene instructions is that they can get very complicated. So I'm just adding V, which is going to be the position, the add value, which is going to be the rate. Let me try just for a test. I don't know. That's just crazy. So this value plus voice, constant inter-voice. The mixed voice should be from 0 and all the voices. Yes, that's correct. Really don't know. Okay, I'm going to figure this one out. I'm just going to be right back. Going to just a minute, okay? You'll be back very shortly. I'm back. Just going to do something here on my aquarium. Okay. Oh, I forgot to put the lid on the aquarium. Fishes can escape. See, there's no fish on the floor. One time I forgot to put the lid and the fish was on the floor. Yeah, okay, I'm here. So what I'm going to do, just going to create my code in here. Load. I'm going to load the position. Add the position to the rate. Okay. Now I'm going to compare equal and greater. So position was equal and greater than the wave table size. Yes. And then we do end. The end option took me a lot of time to understand, but it's not so bad. It's just a bit crazy to understand as it uses a different logic, but it works. So by doing this, now we should have and now I have to subtract the position with this result and then store. Let's see if that's correct. Yeah, that's correct. So I'm doing something wrong with my sim instructions in there. So let's try. If I go subtract that, and I want to store the output of this. Why it's not working? It's probably something I'm overlooking because I'm a bit tired today. So it could be that. So I apologize for that. I'm going to take one final look at this and just retire for today. I'm going to do a few things in here. Alright, seems to be fine. Because there is some limitations on the sim instructions that I created, but I don't remember what it is. I remember one thing, but there's another thing that I don't remember. I'm starting to think that that could be the problem. So let's see. Position expose equals position. I don't know, maybe that's one of the limitations that I'm remembering now. No, it's not that. Well, just for the sake of testing, I'm going to just rename the variable add, maybe use it somehow. I doubt that. Yeah. But always has to check. Oh, bloody crap. There is a problem in here. This and this. I'm using that. I don't really remember. Let me check. I think that's the problem. No, it's not a problem. So let me check. Compare the two values. The one that I just added. I see a problem. I see a big problem actually. First I have to add, okay, it's a logic problem and I can fix it. First I have to add the value and then I compare the value, otherwise I subtract the value by the result. That's why it was not working. See, logic can get in the way sometimes. Now I'm wondering what's the difference of using these comparing to the what I was using on the other ones. I don't get it. So now I have to fix on the AVAX code as well. It's not a big deal. Over here, LVS V equals. So I'm adding first, then I have to compare it with the rest of the code later. Okay, not bad. Now I can try if I can do a more direct approach now. That's so weird. was scratching. Oh, okay. We have something at last. So it's working. Let me check what's the benchmarking of this guy compared to before. Yeah, that's not bad. Let's check the previous values. Considering that I have added stuff, it's not so bad. Let me try something out. So AVX 41. What happens if I double this, because it's going to use the cache in memory, and sometimes memory, no, it's slower, much slower, but sometimes memory takes a bigger hit than a multiplier or addition and stuff like that. Let's see with SSC. "46. This is just 4 numbers, maybe it's not so bad. Yeah, pretty much the same thing. 46, 57. And it's more harder to understand the code if you look. 47. Yeah, I'm not going to mess with that one. But now, okay. We need to write the output. So we write the first sample, and then write the second sample, but the second sample we need to multiply by the what's the name again? Samples interpolation. But I need a sample interpolation 2 times actually, so let me call this sample interpolation equals below the sample interpolation and get the samples, and I want to create, I have an option to invert the value, but I want to create another one, invert and multiply. Well, no, never mind. For the first sample, we just go with the interpolation inverted. then sample interpolation invert, and then we write to the output, and it's correct. And the second sample we just multiply by the sample interpolation. So when the sample interpolation value goes from 0 to 1, as it's closer to the first sample, it's going to be 0. So if we invert that and multiply for the first sample, it's not going to change the first sample if it's close to 0. And as it goes closer to 1 for the second sample, it's going to multiply the second sample. And in this case, we don't write the output, we actually sum this whole thing, and then we write the output. Okay. So now it's a matter of checking what's faster. So 52 and 47. If I can go like so let's say create first sample, samples 1, just be sure that's the first one, samples 2, that's the second sample, and now we get samples 1 multiplied by the sample interpolation invert plus samples 2 multiplied by the sample interpolation regular and now we write this to the output. Nice. Oops, I made an error somewhere. Oops. I reused a variable name, the output variable. Yeah, that's pretty much the same values. 52 and 46 was 47. But I guess we could go just like T. So the code knows that this is a single instruction and just write this directly. Oh, crap. $51.46. That's good. But we can do better. That's the fun of FMA3. Because you can do a multiplying and addition in 20% less code. Sorry, CPU cycles. It has a latency of 5 compared to a latency of 8 when you multiply two numbers and add one number. So first let me write these numbers just so you know we reduce it something. Put this in here. Remove all this because now we're changing code a lot. So I created a small sim instruction in here called multiply and multiply add this. But before I do that, I want to add in here the volume to have the samples, sample universe, and all these times the volume. So let's see what's the performance in hit of this. Because we're about to start oversampling and add the filter, and that's going to be very time consuming for the CPU. So that's why I'm trying to improve things in here. So let's see. We'll get multiply and multiply add this, which we can go like this. Let me show to you. So st voice volume, voice volume, and then we multiply these two guys, samples interpolation here. We put this in new line so it's easier to see. Samples interpolation plus samples times sample interpolation. Yeah, and then write the output. It looks a bit weird, but I got used to that already. So it just multiplies the volume by, first it's multiply the samples for the sample interpolation, then it adds this other process here, which is samples by the sample interpolation, and then multiplies by the volume and writes to the output. I don't know, for me it makes sense, and the advantage is that with AVX and FMA3, it lowers the processing time for that. Unless I did something wrong, of course. But it should lower at least. Well, very small. Let me run again and check. Yeah, it's a small lower, but it helps. And I can do this in one line. But one other thing I want to check in here, it's my samples call, because I could just go and put the samples here directly, samples 1 and samples 2. Let me see if it's going to understand my processing this. Yes, it understands. And see if that helps out. 49 or actually got higher. I don't know why, but anyway. Oops, this is wrong. I made one small mistake there. Maybe that's why I was scrapping the code. think I have to do it in a different way in here. Samples interpolation, and this I have to tell the compiler that this is a sim instruction. There's a lot of things to worry about. Not a lot lower, but let's try something here. Let's add more time to the processing. Copy this and put it back the old code, just so we can compare better. So this is the old code, this is the new. There's the volume missing in here. Volume times all this guy. Okay, let me check now. Oh. What? Where? This one. Oh, because I want to first do this and then do that. Okay, never mind. Correct now. Volume times the two samples and the interpolation. Let's take a longer time now. But the advantage is that with a longer time, we have a better idea if it's running faster or not. Because right now, the code is simple, but it's going to get very complex and very fast. So let's try this now. So samples 1, samples 2. Oh, I forgot to remove something. I forgot to remove these two guys. My eye is really twitching today. I'm twitching the eye on Twitch. So lame. Boy. So it's pretty much the same. Let me check if I'm actually loading it incorrectly. Interesting. So let me use the samples 1 and 2 as use it there. Samples 2, sample interpolation, and then the volume multiplied by that. Don't get it. Should run much faster. FX, AVX. I'm starting to think that when I inline the call, I should always use the commercial E. That could be one mistake. Yeah, it's lower now. Now it's more correct. It looks like I made a mistake here on my sim instructions. Let me fix that. So I have my float values. Because this tells the compiler to do things in a different way. Really, put the things on the right place. Because the other ones I did do right. I don't know why I did that one incorrectly. That's easy fixed. So let's fix it now. Okay, now it's all fixed. Oh, or not. Let me check what I did wrong now. What? Let's complain about. I don't even have that. Weird. That's weird. Ah, I know what it is. In this case, I can use that and I can use that. Never mind. This and this is wrong. Because it's a constructor. That's why I was wrapping all over the place. Now we have a better idea what's going on. You can see that already got lower, of course, because it's properly inlining everything. And that's what I want. And now I can compare the two codes. What happens? $37, $35, so it is lower. It's good. That's what I wanted. Now, being stubborn that I am, I want to use this directly instead. So I have to use P times sample internal inverted. Yes, correct. Now it's correct. Because now it's much lower. When I was doing just the samples times sample interpolation, I was trying to do something different in terms of code, but I fix it now. Because when you start using this type of coding, you have to be careful because the compiler is not going to know what you want to happen. So now let's try something different. Let's oversample by 16 times. And let's call this on the mix voice. We have to go like for it. Per sample equal to 0 x times per sample. XO sounds a bit weird. And then we don't write the actual output, we have to actually first zero the output variable. So I need to create another function for that. Set 0. So it's t set 0 voice output. And then we can't go like this. We have to get all this output. It's going to be like t x out equals output. So t0 is before the oversample. And then we have to keep adding to the output. So we load the output, we add to everything else. Yeah, that's it. But in this case, we have to get the output and multiply it. Output, we're going to get the output times 0 output divided by the oversample and write to the output. Division is really not a good thing. You always use a multiplication instead, so I'm going to replace that in a minute. Because that's really going to crap code. It's already taking too long. That's not good. Or it just crashed. Let me double check. So oversample 16 is too much. Let's put 4 times. Yeah, it's taking a lot of time now. Just with 4 times oversampling. But I'm not filtering or anything, so I'm just doing this for testing. But let's see if it does produce any sound. I have to add something before I can test actually. So on the eighth table, on the rates, update rate, oh, it's there already. Separate times oversampling. Yeah, it sounds sucky. So let's oversample by 32 times. But since I'm not filtering, that's why it sounds so bad. I need to create a filter now. You can see that it doesn't do anything if you don't filter it out. So that's going to be the next step, to filter this output. Because right now I'm just adding to each voice, and then I divide it well, this division is actually not correct. Actually. But anyway, that's going to be for the next video. I'm going to create the filter and everything else. So that's pretty much it for today. They are a bit slow, the video is a bit short, but at least I'm trying. So thanks again for watching, and see you guys next time. It was nice to code all this, and if you have questions, please send it over. And I have updated my GitHub page with all the changes I have done with the instructions I created. But as we talk, this is more for me to use because I can understand this, I can use and hack this over, and it works for me. It makes sense. But for other people, they're going to see and say, "What? Is he crazy? Why do that?" But it works for me. That's all I can say. So again, thanks for watching and see you next time.